The neutral conductor in a range circuit can indeed be derated according to the National Electrical Code. The specific section that addresses this is found in the National Electrical Code, specifically Article 210.19 FR. This section outlines the requirements for the feeder conductors for household ranges and cooking appliances. Understanding this section is crucial for ensuring safe and compliant electrical installations in residential settings. The key to derating the neutral conductor lies in the understanding of the load characteristics of a typical electric range. Electric ranges typically consist of heating elements and other components such as timers and lights. The heating elements produce a balanced load, meaning that the current flows equally through all phases of the circuit, thereby minimizing the current in the neutral conductor. The National Electrical Code recognizes this characteristic and permits a reduction in the size of the neutral conductor. Article 210.19 FR provides specific guidelines for calculating the minimum size of the neutral conductor. It states that the neutral conductor shall have an ampacity not less than 70% of the ampacity of the ungrounded conductors. This means that if the ungrounded conductors, also known as hot wires, are rated for a certain amperage, the neutral conductor can be rated for 70% of that amperage. For example, if the ungrounded conductors are rated for 40 amps, the neutral conductor can be rated for a minimum of 28 amps. This derating is based on the assumption that the maximum unbalanced load in the neutral conductor will not exceed this 70% threshold. Several factors contribute to the validity of this assumption. Firstly, the heating elements in an electric range are designed to operate at or near a balanced load. This minimizes the current flowing through the neutral conductor. Secondly, other components such as timers and lights typically draw a relatively small amount of current, further reducing the load on the neutral conductor. Thirdly, the National Electrical Code requires that the neutral conductor be sized large enough to carry the maximum unbalanced load, even with the derating factor applied. It is important to note that the 70% derating factor is a minimum requirement. In some cases, it may be necessary to use a larger neutral conductor to accommodate specific load conditions or to comply with local electrical codes. Electrical codes can vary from place to place. When determining the appropriate size for the neutral conductor, it is essential to consider all relevant factors, including the rating of the range, the characteristics of the load, and the requirements of the local electrical code. Article 210.19 FR also includes an exception for ranges with a maximum demand of 8.75 kilowatts or more. In these cases, the neutral conductor shall have an ampacity not less than 70% of the ampacity of the ungrounded conductors, but it shall not be smaller than number 10 American wire gauge copper or number 8 American wire gauge aluminum. This exception ensures that the neutral conductor is adequately sized to handle the potential load of larger ranges. In addition to Article 210.19 FR, other sections of the National Electrical Code may also be relevant to the sizing of neutral conductors and range circuits. For example, Article 220 provides general requirements for calculating branch circuit, feeder, and service loads. This article includes tables and guidelines for determining the demand factors that can be applied to various types of loads, including electric ranges. Demand factors are used to reduce the calculated load based on the assumption that not all loads will be operating at the same time. Applying demand factors can result in a further reduction in the size of the neutral conductor. However, it is important to carefully consider the specific load conditions and the requirements of the local electrical code before applying any demand factors. It is also important to understand the difference between a neutral conductor and a grounding conductor. The neutral conductor carries the unbalanced current from the load back to the source. The grounding conductor provides a path for fault current to flow back to the source in the event of a short circuit. The grounding conductor is typically sized based on the size of the ungrounded conductors, and it is not subject to the same derating factors as the neutral conductor. The National Electrical Code provides specific requirements for the sizing and installation of grounding conductors in Article 250. When installing a range circuit, it is essential to follow all applicable requirements of the National Electrical Code and the Local Electrical Code. This includes properly sizing the conductors, installing the appropriate overcurrent protection, and grounding the equipment. Failure to comply with these requirements can result in electrical hazards and code violations. In summary, the neutral conductor in a range circuit can be derated according to Article 210.19 of the National Electrical Code. This section allows the neutral conductor to be sized at 70% of the ampacity of the ungrounded conductors, with certain exceptions. However, it is important to carefully consider all relevant factors and to comply with all applicable requirements of the National Electrical Code and the Local Electrical Code. For example, consider a scenario where a household range is rated at 12 kilowatts and operates on a 240-volt circuit. To determine the appropriate conductor size, firstly calculate the current draw of the range. Using the formula power equals voltage times current, we can rearrange it to current equals power divided by voltage. So 12,000 watts divided by 240 volts equals 50 amps. This means the ungrounded conductors, the hot wires, must be rated for at least 50 amps. According to the National Electrical Code Table 310.16, which provides ampacity ratings for conductors, a number 6 American wire gauge copper conductor with THHN insulation is typically rated for 55 amps, which would be suitable for this application. Now, to determine the size of the neutral conductor, we can apply the 70% derating factor allowed by Article 210.19 FR. 70% of 50 amps is 35 amps. Therefore, the neutral conductor must be rated for at least 35 amps. Again, referring to National Electrical Code Table 310.16, a number 8 American wire gauge copper conductor with THHN insulation is typically rated for 40 amps, which would be sufficient for the neutral conductor in this case. It is important to remember that this is just an example, and the actual conductor sizes may vary depending on the specific installation conditions and the requirements of the local electrical code. Factors such as ambient temperature, conductor bonding, and the type of insulation can affect the ampacity of conductors. Therefore, it is always recommended to consult the National Electrical Code and a qualified electrician to ensure that the conductors are properly sized for the application. Furthermore, it's important to understand the practical implications of derating the neutral conductor. While the National Electrical Code permits this practice, it's crucial to ensure that the electrical system is designed and installed in a way that maintains safety and reliability. Overloading the neutral conductor, even if it's within the derated ampacity, can lead to excessive heat generation, insulation damage, and potentially fire hazards. Therefore, a conservative approach to conductor sizing is always recommended. In addition to the conductor sizing, it's equally important to select the appropriate overcurrent protection device for the range circuits. The overcurrent protection device, typically a circuit breaker or a fuse, is designed to protect the conductors from overloads and short circuits. The size of the overcurrent protection device should be matched to the ampacity of the conductors. In the example above, where the ungrounded conductors are number 6 American wire gauge copper rated for 55 amps, the overcurrent protection device should not exceed 55 amps. This ensures that the conductors are adequately protected from overloads. The National Electrical Code provides specific requirements for overcurrent protection in Article 240. This article includes tables and guidelines for selecting the appropriate overcurrent protection device for various types of circuits and conductors. When installing a range circuit, it's essential to follow these requirements to ensure that the electrical system is properly protected. Grounding is another critical aspect of range circuit installation. The grounding conductor provides a path for fault current to flow back to the source in the event of a short circuit. This helps to protect people from electric shock and to prevent damage to equipment. The National Electrical Code requires that all exposed metal parts of the range be grounded. This includes the range chassis, the oven door, and any other metal parts that could become energized in the event of a fault. The grounding conductor should be sized according to National Electrical Code Table 250.122, which provides minimum sizes for equipment grounding conductors. The grounding conductor should be connected to a grounding electrode system, which typically consists of a ground rod or a metal water pipe that is buried in the earth. This provides a low impedance path for fault current to flow back to the source. It's important to ensure that the grounding connections are properly made and that the grounding system is effective. A poor grounding system can increase the risk of electric shock and equipment damage. In addition to the technical aspects of range circuit installation, it's also important to consider safety precautions. Working with electricity can be dangerous, and it's essential to take appropriate safety measures to protect yourself from electric shock. Firstly, always disconnect the power to the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the range circuit. Secondly, use insulated tools when working on electrical circuits. Insulated tools help to protect you from electric shock in the event that you accidentally come into contact with a live wire. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Safety glasses help to protect your eyes from flying debris, and gloves help to protect your hands from electric shock. Fourthly, never work on electrical circuits when you are wet or standing in water. Water is a good conductor of electricity, and it can increase the risk of electric shock. Fifthly, if you are not comfortable working on electrical circuits, hire a qualified electrician to do the work for you. A qualified electrician has the training and experience to safely install and repair electrical circuits. In conclusion, derating the neutral conductor in a range circuit is permitted by the National Electrical Code under specific conditions outlined in Article 210.19 of FER. However, it's crucial to understand the technical requirements, safety precautions, and practical implications of this practice. Always consult the National Electrical Code, local electrical codes, and a qualified electrician to ensure that the range circuit is installed safely and in compliance with all applicable regulations. By following these guidelines, you can ensure that the electrical system in your home is safe and reliable. Understanding the principles behind these regulations helps in creating a safer electrical environment. Moreover, regular inspections and maintenance of electrical systems can prevent potential hazards and ensure long-term reliability. This information is intended for educational purposes and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. The electrical codes and regulations are subject to change. It is very important to use the latest edition of the National Electrical Code and any local amendments.